Thank you for coming. My name is Andrew Shaw, and I am a product development engineer at IDEX Health and Science. IDEX Health and Science is a manufacturer of OEM components for devices in the IVD bio field. And today we're going to talk about some new components we're starting to offer for instrument manufacturers. And they would be sensors. We have a pressure sensor and a flow sensor we're going to talk about today. So we're going to talk a little bit about how we develop these sensors for our customers. So we went to our customers and we really wanted to see what kind of challenges they were seeing when designing an instrument and what specifically was difficult for them during instrument design. One thing that a lot of customers talked to us about was everybody wants data from their system. They want as much data as they can get from their system. It makes a lot of sense. You want to make sure that you aren't getting pressure where there shouldn't be pressure. Or sometimes it's as simple as making sure that the fluid is flowing in the right direction. It sounds pretty simple, but from my personal experience, if you put a solenoid valve on a system, it can actually create some pumping action and move your flow backwards, and that can cause contamination. It's not a good thing. But that's something that you wouldn't necessarily know happened if you didn't really have the data from your system telling you that. Another thing that a lot of customers are coming to us for is they want confirmation that an action actually took place. They want proof that a reagent was dispensed. What we think these sensors will help with is just that, is getting some confirmation from your system that it is doing exactly what you want it to do. Another important aspect that customers want sensors for would be to monitor their system over time. And this one's pretty exciting. Periodic maintenance of systems right now is done through testing ahead of time. You say, how long does it take for something to happen here? Now you can actually monitor your system over time and see, that pressure looks like it's rising a little too fast during this step of our process. Maybe we should go in and change something in that. And what sensors allow you to do is monitor trends over time and make sure you don't have a catastrophic failure in the middle of a test that has samples from a patient that you can't really get again. It's important for the IVD bio field to not have these kind of mess ups, and sensors will allow you to keep your machine up and running for as long as possible with no surprise failures. So we took these challenges from our customers and we said, what specifically do you like to see in a fluidic component? What do you like to see in them? The first one was low internal volume, and that's pretty obvious. It's a growing trend. Everybody who comes to us for fluidic assemblies always says, we want to have really low internal volume. We want to waste as little reagents as possible. And it makes sense. Reagents can be very expensive. Also, you can get more runs done with the same amount of reagents if you have a lower internal volume. So we tried to focus on that as well. Also, a fully swept path was another request from many of our customers. They said, we can't really have a dead end in our system. What a dead end will do is trap a bubble, and that may cause problems with dispense accuracy. It also creates some carryover issues. So if you are flowing two reagents through a fluidic path with a dead end, the reagents may end up mixing and can cause some pretty bad effects in some cases. One more thing that customers wanted was they wanted it to be easy. They said, hey, don't make this complicated for us. We just want to slap it on our machine. If we're curious about what kind of information, what kind of data is coming out of one fluidic line, for example, we just want to be able to plumb it in very easily. So we went about trying to do that. It keeps maintenance easier if you can easily add it and remove it from your system. So we took all that information from our customers, and we went about designing these products, and we're really excited to start showing them off to people. The first one we have here is the pressure sensor. We have two options for this. We're going around saying they're a modular pressure sensor. What we mean by that is there are two options. There's an option to use quarter 28 fittings. So that's just a standard fitting and tubing system to attach to it. We're also offering a manifold mount option. Now the manifold mount option would mount to a flat surface. You could bolt it right on. It's just two screws. It's something like 3 inch-pounds. It's 3 inch-pounds to attach it to a manifold. So that means no special design. It's just simple fluidic paths and allows you to get your prototypes up and running really quickly without having to have a special interface for them. Let's see. We have 1% full-scale accuracy, and our scale is for 14 bars. So in other words, you get around 200 PSI, and this 14 bar absolute. So that means these pressure sensors also measure in vacuum down to 0.25 bar absolute. And you have 1% accuracy across that full scale. So that's pretty good. Like we were talking about earlier, it has a flow-through design. That was really important to a lot of customers. So the flow-through design prevents bubbles from getting trapped in there. It prevents excessive carryover. And it's something that a lot of people are actually excited about for this pressure sensor. For communication, we're using I2C communication protocol, and it operates at 5 volts. And finally, we designed this specifically for the IVD bio industry. So we are only using inert materials in its construction. So we're using PEEK, Viton, and stainless steel. Next up, we have our flow sensor. We're also pretty excited about this sensor. Like the pressure sensor, it is designed in a modular fashion, so you can either connect to it using tubing and fittings, or you can mount it on a manifold for a higher volume application, for example. What the flow sensor does is it gives an output in microliters per minute. This flow sensor is capable of measuring up to 1,000 microliters per minute in both directions. And the accuracy is about 5% of the reading. Like we were saying earlier, quarter 28 flat bottom ports. It's like adding a solenoid valve to the system, actually. It's very simple to add, in the sense that it's very simple to add to any sort of system. Keeping our customer in mind, again, we're offering I2C communication with this sensor. We're also offering UART as a communication protocol with this one. And that just gets you going quicker. It's easy to connect to it and just get reading to it. And for wetted materials, again, we only chose inert wetted materials. We have PEEK, Viton, and borosilicate glass. So we went to a couple of our customers with our sensor designs, and we wanted to see what they thought about them and what they think they could use these sensors for. A couple of customers came to us and said, we want to make a constant pressure flow system. And what you can do is use our pressure sensor to get some sort of feedback control on a pump to create a constant pressure. We think that's a great application for our sensors. We think it'll work very well for it. Another application for the pressure sensor that they had was detecting leak. So for example, you could monitor the pressure within a system, and if the leak were to decay too much over a certain period of time, then you would know that there's a leak within your system. And that's a great way to keep an eye on your system and make sure that you're not spilling reagent all over the floor, for example. The flow sensor is also being talked about a lot with our customers. We had two applications that we've talked to customers about. One of them was thinking of using several sensors to monitor several different flow channels to make sure that they are actually within the flow range that they are looking for. It's good for sheath flow applications, I believe, is to keep a reagent maintained well within it, and you got to really precisely control the flow rates in these, and that's what these sensors allow you to do. Another one, we've heard this a couple times as well, is another customer is looking to monitor the flow rates on the waste side of things. And what the waste side allows you to do is you don't have to worry about this coming in contact, or our sensor coming in contact with your reagents before you use them. Now instead you're just monitoring the waste and making sure that you're getting a consistent amount of flow that you're looking for. It's good for like a peristaltic pump draw system. It will actually, you'll be able to monitor the flow rate and make sure that your peristaltic pump is working the way you want it to work. One final thing that we added with this project, and we're really excited about this one too actually, is our sensor view software. So with the sensor view software, what you can do is quickly and easily pair up to either of our sensors and immediately start getting data from them. It allows you to evaluate the use of our sensors, and how we do this is we provide you a I2C master that plugs right into a USB port on your PC. So you can plug it into your PC, plug that into the sensor, and immediately start getting data from it. Sensor view is pretty cool. You can log data with it. You can zero readings. You can get all different units, PSI or millibar or whatever. And you can run more than one instance of sensor view at a time. So you could connect both a pressure sensor and a flow sensor at once and monitor both of those channels. So it's pretty exciting. We're really happy to help our customers evaluate these products. So yeah, you can buy one or a handful and just immediately start getting information that you previously didn't have. It'd be great. So thank you very much for coming. We appreciate you coming. Thank you.